Good morning, and welcome everybody to Augmented World Expo 2015. Thank you all for coming. We're all really excited to be here. So our first speaker in the design track, right, we figured that out? Yeah. Okay. Is Mark Billinghurst, who Ori, the organizer of this whole event, has described as an augmented reality god. So this is going to be a really, really interesting session, and I'm just going to pass it right off to him. So, Mark Billinghurst, everybody.
Great, thanks for that. So thanks for everybody coming. Hopefully you're here for the course on how to rapid prototype for wearables. It was supposed to be in the room across there, but they just moved over to here. So as I was introduced, my name is Mark Billinghurst. Until a couple of weeks ago, I was at the HIT Lab New Zealand at the University of Canterbury, and I've just moved recently to the University of South Australia to help start a new lab over there, so it's very exciting to be here. So to give you a bit more background, this is me. So I used to be the director of the HIT Lab New Zealand. I was there for 13 years, and before that I got a PhD from the University of Washington, and I've been working on augmented reality for almost 20 years now, so it's been a long time. My research work focuses on augmented reality, mobile HCI, and collaborative interfaces, and I've published quite a few papers in those areas. And I was very fortunate about a year and a half ago to spend 5 months with the Google Glass team working up here in Mountain View on sabbatical. So I've got some insight into how the glass hardware was developed and everything. So that's a little bit about me. I was hoping before we get started to find out about you. How many of you would describe yourselves as programmers or developers? If you put your hands up. A few of you. How many of you don't program? And just one person? Actually more than that. A few people. Great. How many of you describe yourselves as designers or... thank you. Great. So it looks like kind of an even split. So normally when I teach this course, it's normally over a longer period of time. So this is a reduced version of it. And what we're going to focus on today is how to rapidly prototype wearable interfaces, specifically for head-mounted displays, without requiring any programming or very little programming experience. So I'm going to talk a little bit about some interface guidelines for if you're building wearable interfaces for Google Glass or for the Recon Jet or for other types of wearable displays. And I'll show you a range of different prototyping tools that you can use without requiring any programming, and then also provide you some links to further resources. And so I have a very brief schedule. Also, I was hoping to pass around a sign-up sheet, but maybe we won't do that. But I'm happy to share with you all of the material I show you. So you might want to write down my email address, and if you send me an email, I will send you the slides and all the videos that I'm showing you as well. So, and if you want the expanded version of this, if you go to SlideShare and look for my name, you'll see other versions of the Glass class that have been taught at other conferences that are 3 or 4 hours long. So there's lots of material there too. So about 10 years ago, I was in Germany and I came across this computer. This is a Z25 from 1956. This was state-of-the-art right after the Second World War. It cost about $40,000, and the processor ran at 2.6 kilohertz. So very slow, very expensive. You can see they've got a typewriter keyboard, a rotary phone, some sort of bar there, and some paper output. So of course, in the 50 years since then, computers have come a long way. And people often say they've kind of these 4 generations of computing, where you've got computers that started at room size, and they've gone down to the desktop and the laptop. And the last 10 years or so, of course, the focus has been on what's in your hand, the smartphones. And then most recently, the last couple of years, it's been on the head. And so we've evolved to where you've got Google Glass and other wearable devices. Although, of course, wearable computing has been around for a long time. The first wearables were developed in the 1960s. So it's only the Google Glass and the other displays we see now are really like the second generation of commercial systems. A wearable computer is generally defined as one that's always on, always accessible, and always connected. And it has other attributes such as being able to augment the user's actions or being aware of the context and the surroundings. So if you trace the history of wearable computers, it kind of goes through these 4 phases, where the first 30 years were a lot of early exploration. People like Steve Mann, who you'll see this afternoon giving a course, has been wearing a computer since the late 80s, and a variety of hackers have built together their own custom systems. Then from the 90s, universities like MIT, the MIT Media Lab established their own wearable computing group, Georgia Tech and Carnegie Mellon. And then finally, about the mid-90s, the first commercial systems arose. Most of those failed in the market, and now we've kind of got the second wave of commercial wearables now with systems like the Recon Snow and the Recon Jet, which are more customized towards athletics and skiing, and of course Google Glass that became available a couple of years ago. So here's the Recon Jet, and of course the Google Glass. How many of you have tried, or how many of you haven't tried Google Glass? Anybody not tried it? Oh, okay, a few. So what I'll do is I'll pass around one of my Google Glass displays here, and those of you who haven't tried it can try it while I'm talking. So there's a boring spot in the workshop. You can take photographs or whatever. So this is one of my Google Glass display units, and basically what you have is a micro projector here, a touchpad here, and a camera and a processor. So you're basically taking a cell phone processor and squeezed it down and put it into the touchpad here, and then the battery at the back here. So when you put it on, the Google Glass display is almost always off to save batteries. So when you put it on, if you tap on the side of the display here, you'll see some information appear in front of your eye, and it looks kind of like this. So this is a peripheral display, so it's always up in the top right-hand corner. And with Glass, there's several ways you can use it. One way is by using gestures. So you swipe horizontally, you tap, or you flick down. You don't push up. It doesn't do anything except give the bird to the person next to you. So just tap and it'll come on. If you can't quite see it, you can bend the display a little bit, and then you can slide along. You'll see a couple of things there. And the other option is a button on the top. If you push the button, then it'll take pictures as well. And you can use speech input, but maybe a bit noisy today. So I'll pass that around, and you can try it out if you haven't tried out Google Glass. And down on the show floor tomorrow and the next day, you'll see a wide range of other wearable displays. So here's a bunch of other wearables that are coming to the market, either in the market now or are coming out in the next 3 to 6 months or so. So you can pass that around. Don't break it, otherwise you'll buy it. So take care with it. So Google Glass represents, in many ways, the peak of wearables because it's very, very wearable and consumer-friendly, as you can see. Before that, wearable systems were big backpack systems or custom-mount displays on your head. So what I want to talk about now is how you design interfaces for this, and then we'll transition into actual prototyping and showing you how to actually get things onto the display. So one of the questions is, how do you design for devices that are on your head or on your arm or other wearable devices? One of the most important attributes of wearables is they're very intimate technologies. They're on your body or near to your skin. And so that means that when you design for wearable systems, you have to design for very human elements such as attention or social interaction or user experience design. So I'm going to talk about each of those briefly and show some examples of those, and then we'll transition into the prototyping part. So first of all, with wearables, attention is very, very important. So when people use mobile phones, they often split their attention between the real world and between the display. You've all seen the funny videos on YouTube of the person walking along and falling into the pothole or walking into the tree or whatever else. And so when you're dividing your attention like that, the focus is on micro-interaction. So you want to be able to have a very small interaction on the screen that doesn't require you to take a lot of attention from the real world. So typically, with a mobile phone, this diagram here shows the blue is your attention in the real world. The red is the time it takes to acquire the phone, and the white is looking at the phone screen. So with a mobile phone, typically you're splitting your attention between the real world and on what's on the screen, and it takes some time to do that attention swapping. With a wearable device like a watch or like Google Glass, you can swap between the screen and the real world just simply by moving your eye or moving your wrist a little bit. So the amount of time is much, much faster. So that means the interaction times are very quick. So you can see here with a PC, you typically plan to use a PC for about 30 minutes at least at a stretch, and you're often sitting down, you're doing focused work, whereas you contrast that to a smartwatch or a wearable display, it's often unplanned use. You want to use the device while you're walking or engage in other real-world activities, and a lot of what you're trying to do is you're really looking at notifications of information or multitasking rather than a focused task. So there's a very interesting study done a few years ago in Finland by Antti Olsvaata, and he had people read text on a mobile device while in different environments. So on the right-hand side, he had people read text on the mobile device while they were in the laboratory, and people on average, and he tracked how long people looked at the screen versus looked at the real world. So in this case, on average, they looked about 14 seconds or so at the screen before they looked away. But if they're walking down a busy street, then the average screen time was about 4 seconds before they looked back to the real world, just to avoid colliding things. And this is a graph of how many times they divided their attention between the real world and the screen. So on average, when they're walking on the busy street, about 8 or 9 times they were swapping their attention back and forth before they finished reading a single page of text, whereas in the lab, only once. So what that means is that if you're designing for a wearable device, either a watch or a head-mount display, you need to be able to design interfaces that can be comprehended in a very short amount of time. So when you're trying to design for micro-interactions, you want to design interaction that lasts for less than a few seconds and require only tiny bursts of interaction or attention, and generally only one input or only one task per screen. In fact, in the US, the Transport Association has put out guidelines for technology use in cars, and what they say is that if you're putting a technology into a car like a GPS system or in-car entertainment, then the driver should be able to complete a task using that system in less than 2 seconds. So they only take your attention away from the road in 2 seconds or less. So the basic rule of thumb is that if you're building a wearable interface, the interface should not take more than 4 seconds to complete a given interaction task or a given step. So that's one element of attention. The second element is interruptions. So if you're wearing your wearable device or your smartwatch, then oftentimes you're engaged in other real-world tasks. And if I'm driving along the freeway, I don't want to see my email blasting in my face when I'm driving along the freeway. So you need to be able to filter and design a very graceful way to be interrupted from your real-world task and what's the information being shown. So for example, with Google Glass, they do this very well. If you're wearing glass and you get an email, the first thing that happens is that you get an audio tone in your ear without showing any visual information. If you then look at the display automatically turns on, has some eye gaze tracking, and it shows you the header of the email. So it requires a bit more attention, but it's still not requiring your full attention. And then if you tap on the trackpad, it will then go into the body of the email and allow you to start generating a reply. So it's only when you start doing the reply that it requires your full attention. So you can see in this case what happens is you have a ramped up engagement. So it's a very elegant way of dealing with interruptions. The other element of designing for attention is considering the cognitive load or the amount of mental ability it takes to interact with the system. So this is a little axis showing when you're developing computer interfaces, you can put them on this axis here of low cognitive and perceptual load and high load. So for example, sensors that work automatically don't require any of your attention, so that's very low cognitive load. But if you're using your iPhone and you're playing Angry Birds or something, then that requires a very high cognitive load because you're directly manipulating with the screen. So if you're developing an interface, you have to consider where along this continuum your interface is going to sit and how much of the user's attention it requires to use. And similarly, you can also get attention from the output. So on the right-hand side, if you're wearing your Oculus Rift VR display, then the system is capturing your full attention because you can't look away from the screen. On the left-hand side, if you've got an agent-based system, like maybe a web-based travel agent where you put some specifications in that goes out and gets information for you, and this doesn't require any of your attention at all. So again, when you're designing a wearable interface, you've got to consider what output am I going to generate and how much cognitive load does that take up. So that's a little bit on the attention side. Let's talk about social interactions, and in particular social acceptance. So the basic rule is with technology is that people don't want to look silly. It's a surprising fact maybe, and that was one of the reasons why I think glass has not been so well accepted amongst general consumers as a consumer device. Because when you wear this on your head and you go to the pub, then you're going to look silly. In fact, there's a survey done of about 4,500 people last year, and only 12% of those people would be willing to wear AR glasses. And there was another survey done of mobile AR users, so people using tablets or phones for AR, and 20% of them had experienced some social issues, like when you walk around with your tablet and looking at an AR scene, maybe people think you're taking photographs of them and they get upset, or other things start happening. So in many cases, acceptance of wearable displays is more about social issues and technical issues. You know, Google does a fantastic job of squeezing a lot of technology into this very small strip. But when I go out in a public place and people start laughing at me or try and pull the display off my head, then that's a big social issue. So one of the rules of thumb is that you have to think of fashion first, and it doesn't matter what the device does unless the wearer is willing to put it on and to wear it. And I think that's why watches are seeing a lot more acceptance than head-mount displays, because people already wear watches, and so that is quite socially acceptable. Here's an interesting example of that. The Swiss company TAT, about 5 years ago, produced a concept video of what they called the augmented ID. So the idea was you go to a meeting, you don't know people in the meeting, so you pull your phone out and you scan the meeting and does face recognition, and then around the faces it puts icons representing LinkedIn or Facebook or other things of those people. And if you want to, you can tap on the icon and get their Facebook accounts, and it's a great way to connect with people. So you can see here's the meeting with the person with their Twitter and their, I guess that's, is that MySpace? I'm not sure. And lunch appointment there appearing around their face. So that sounds really great, because you can now find information about the person just by looking at them. But then if you think about the social context, if you're in a meeting, a business meeting, we're all sitting in our suits, and I pull my phone out and start doing this, how is that going to make you feel? When they talk to people about this, they said, well, you know, maybe it'll make you feel like you've been stopped by the police for ID or security scanned, or somebody's asking to see your papers. And one person said, anyone pointing a device in my direction to try and identify me better prepared for either a lawsuit or a punch in the face. So, you know, nice idea, but then you think about the social use of it and it kind of falls down. So it's very important when you're starting to think about building wearable interfaces to think about social interaction. Similarly, you know, at the show floor, you'll see a number of companies that are building gesture-based systems, like Meta and other companies, that will be able to interact with AR with gestures. Fantastic. So what happens when I'm in the pub and I'm standing there with my display on and doing this in the pub or in some other social setting? What are people going to think about me when they see me waving my hands around in space in the middle of nowhere? So one of the rules of thumb is to make the interface not usable not just for the user, but also for the people around the user, both physically and socially. And that was one of the challenges with the glass, because people knew there was a camera on it, so when I go to the pub with my glass display, nobody knows if I'm taking photographs of them or if I'm recording what's happening or anything else. So the last thing I want to talk about briefly is the user experience. So wearable devices are really devices that are focused on the here and now. So you can see here, when you've got a cloud computing, whatever you put into the cloud, like your Dropbox or your Google Drive, you expect it to be around there forever. Things on your laptop may be around for a year or two. Hopefully things on your cell phone stay for a week or two. But with wearable devices, they're designed to capture information immediately, show you information immediately, and then it goes away. So it's very, very immediate. So when you're designing for wearables, you have to think about that the users wants to interact in the real world, and the world is the experience, and what you're trying to do is just enhance their experience in the world. You really have to consider your user. So if they're a wearable user, they're probably mobile, they probably only have one hand or no hands free. As I said before, with a divided attention, a very short attention span, and so forth. And you also have to think about the use cases. So for example, if you're wearing your wearable device in a subway train, how are you going to take a note there? If you're walking down the street, how will you record a message on your wearable device? Or if you're in a meeting like this one, or if you're disabled, how are you going to be able to use a wearable device? So one of the rules of thumb, again with wearable design, is providing multiple ways of accessing the same functionality. So for example, with Google Glass, there's at least 3 ways that you can take a picture. You can use voice commands, so when you see the clock with the OK Glass on it, you can say, OK Glass, take a picture. You can touch on the touchpad, or you can wink. You can also push a button as well, so there's 4 ways at least. And whichever you use depends on the context of use. If I'm riding my bike along, then maybe I want to wink with my eye and it'll take a picture. If I'm during a meeting, or if I'm riding a bike, I can use voice commands. Or if I'm doing a meeting, maybe winking is a better way to take a photograph or whatever else. The other thing to consider about is the design for the device. So this is Instagram, I believe, and you can see on the right-hand side, this is the Instagram interface on a tablet or phone, so multiple windows, multiple pictures, but on the glass display, it's only one picture taking up the whole screen. So you've got to think carefully about the device design. And one easy way to think about it is that using a wearable computer is really like using a rear view mirror in the car. Now, when you're driving a car, you don't normally drive all the time looking in the rear view mirror, but you look up occasionally to see information, and then you drive like normally. So just like a rear view mirror, when you're designing a wearable interface, you have to, for example, make it glanceable. So here's two different ways of doing an interface for some sort of running application. And they show kind of the same thing. So on the left-hand side, here's a step counter, nice picture of some shoes. It says you're 87% towards your goal, and you've got 2,600 steps to go. On the right-hand side, it's just showing you the percentage of the way around to the goal. So if you look at the number of eye movements it takes to understand this picture, on the right-hand side, you can pretty much understand it just by looking at 3 different places on the picture. On the left-hand side, there's at least 5 or 6 places you've got to look at the screen to get all that information. So again, with your attention, if you measure those eye movements, maybe it's less than a second to understand what's happening on the screen here, and maybe this side, it's almost 2 seconds. So again, when you're designing for wearables, think about it's a rear view mirror. When I look in the rear view mirror, I want to understand things immediately, not have to spend lots of time on that. You also have to think about the glanceability of your design, and so if I'm waving my watch around or running with my Google Glass display, I need to have to understand it when it's being jostled around and blurred around as well. We talked already about doing one thing at a time and only showing one thing at the screen at a time. Since it's a wearable system and you've got information that might be superimposed over the real world, you should think about what happens when you've got different backgrounds. And if I'm wearing my Google Glass display or my Recon Jet outside in bright sunlight or in a darkened room, how's that going to look at? You want to try and make sure your information you're showing is relevant to the real world task and doesn't get in the way of what you're doing. So you're going to the aquarium, you want to see information about fish. If you're going shopping, you want to see a shopping list. If you're biking, you want to be able to see navigation information. And then finally, when you're building a wearable system, you have to think that most likely the person has many wearable devices. If you've got a Recon Jet display, you've probably got a phone as well, you've probably got a laptop, maybe an activity monitor, and there are hundreds of devices coming to the market right now. So you should think about how you can design your device to work within the ecosystem of devices people will have. So here's some basic guidelines we talked about. I've gone through this a little bit quickly, but like I said at the beginning, I'm happy to share all these slides with you. So don't worry about writing frantically or taking photographs of the slides. At the end, I'll show my email address again. Just email me, and I'll give you all the material. So in summary, from a user experience perspective, 3 of the most important things you've got to think about when you're designing wearable interfaces is attention, social use, and the user experience of how it's usable. So let's talk about prototyping and how we can actually start to do some design, even with no coding experience. So my background is as a user designer, and one of the most important things I've learned is it's really important to prototype. Prototyping allows you to quickly create a visual design of what your interface is going to be like. It allows you to focus on the user experience right away and to communicate key design ideas. So there's a really great video that I'm going to show you part of right now from Tom Chi. Tom Chi was one of the initial Google Glass design team. And in the video he asked the question, how long do you think it took to build the first prototype of Google Glass? The first system that would allow you to have a virtual display showing in front of your face. Does anybody have an idea how long it took to do that? Any takers? 10 minutes? Wow, you should come work for me. You're fast. Imagine what you can do in half an hour. So let me show you the video. It's a long video. It's 8 minutes, so I won't show you the whole thing, so we don't have time. But I highly recommend you watching it. And this is a video that talks about the value of rapid prototyping and hands-on experience. It's a TED talk, so just go to TED and look for Tom Chi and you'll find it.
My name name is Tom Chi. I spent 2 years of my life building the user experience team for the Google X division of Google. And it's a place I affectionately called the Department of Science Fiction because of the futuristic nature of the types of projects we took on. Self-driving cars, Google Glass, and other things that you'll see soon enough. So for those who haven't heard of this project, this is what Google Glass looks like. It allows you to overlay digital things into your eyesight while still maintaining being part of a world. So if I were to pull out my cell phone and look into it, I'm basically out of this world now. Like I'm in my own little cell phone, tablet world, what have you. But Google Glass has the vision of allowing us to continue to be in the world, but also have access to the digital things that we need and we love. Now, I'm going to ask you a really simple question about Google Glass. How would you prototype this experience? How long do you think it would take you to make the first working version of a heads-up display? Okay, a little bit on the long side. The answer is 1 day. And here's what it looked like. So basically, the magic piece is the coat hanger. The coat hanger, I bent it in a specific shape, and the top loop goes around your neck, and then the bottom loop rests against your chest. And it allows me to carry a piece of plexiglass on which a little sheet protector. So these are the things that you put your book reports in so they don't get wet. I literally got it at the drugstore. Have it out at the end of the plexiglass, and then it gets projected onto with the Piker projector that's connected to a netbook. And using this setup, within 1 day, we were already able to start having the experience of what it looks like to have digital things overlaid on your physical world, be able to move around with it, and also use the netbook to try out tons and tons of different ideas around software. Now, after you start getting something like that working, a really important problem comes up. Like, you're wearing this thing on your head. It's like a pair of glasses. So you don't have a mouse or a keyboard or a touch screen, all the ways that you're used to interacting with a machine. So we thought for a second, well, maybe we could do something like what was shown in Minority Report. So for folks who haven't seen that, basically Tom Cruise is manipulating software with his hands in front of his face, and photos are flying over here, and his emails over here, and so on and so forth. So that's the same question again. How long do you think it would take to have the real experience of doing something like that? 2 years, okay. Somebody said 1 day. 45 minutes. So here's how it looks. So you wear the thing that we saw the first time because you need some way to go project things. But what happens is we got 2 hairbands, which I think was the hardest part. We had to go ask people for their hairbands. But you put one hand in each hairband, and attached to that hairband, we tied a fishing line. And the fishing line goes over the top of a whiteboard and then goes down to this little assembly that's taped to the floor. And what this means is every time I move my hand in any direction, it adds tension to the line, and it does the following with the assembly on the floor. So the other end of the fishing wire is attached to a chopstick. And it's not because I'm Asian. There's just a cafeteria nearby. I don't just carry chopsticks on me. But I tied it to the end of a chopstick. I clipped it into a binder clip and then put it over a pen. And basically what happens then is when you move your arm and it produces tension on the wire, chopstick comes down like a lever and clicks a presentation clicker. One hand moves the presentation forward, the other hand moves the presentation backwards. So this was built in 45 minutes, and that meant shortly afterwards, we were having experiences like looking at an image gallery and saying, next image, previous image. Or looking at our emails and saying, let me click into this email. Let me click reply now. And this was exactly the experience of what it was like to go control software with your hands. And ultimately, what it taught us is we probably shouldn't have this in the product. We learned a lot of things about the social awkwardness of it and some of the ergonomic aspects of it that you couldn't have figured out ahead of just thinking about it. And
okay, I'll stop there. So that's a really powerful testament of how important it is to rapid prototyping. Just by a small team with a day and 45 minutes, they were able to test out some of the key ideas about glass and make a lot of progress to understand how it could be used without a lot of investment and a long time of work as well. So what I'm going to talk about for the next 15 minutes or so is how to rapid prototype with tools that are both low fidelity and also high fidelity tools. And even with no program experience, you can start building some mock-ups of what a wearable system would look like. One of the most important things is that almost all the wearable displays, watches and displays available right now on the market run the Android operating system. So it turns out many tools that are available for prototyping on Android will also let you build prototypes for Google Glass or your Android Wear watch or other devices as well. So if any of you are familiar with using Java, Android, or JavaScript or other programming tools that can build Android APK files, they can also be used to build your wearable systems as well. So a typical development process when you're doing prototyping is to go through this. You sketch out your ideas, and then you go down this hierarchy of increasing fidelity and interactivity on your devices until finally you've got interactive prototypes that really work, and then you take the prototypes and give it to your programmers and say, okay, now go and build that, and they go and do all the Java and Android programming for you. So we're going to run through this quite quickly, and I'll show you some different tools you can use along this way to start building your mock-ups. So the first tool is really easy, sketching. Hopefully all of you can sketch on paper. So you can see some examples here of paper sketches of a running app that's been built for a wearable display, and very rough sketches here, but then you can take them to Photoshop or PowerPoint or Illustrator and build nicer versions over on the right-hand side. You can also use paper prototyping. This person's prototyping a smartwatch, so they've drawn a hand on a piece of cardboard with a cutout here, then they've made a piece of paper with all the watch screens on it, and they just slide them through the cutout and get their opinion for what it looks like. Now, it may sound kind of silly, but you know, this is somebody in half an hour who's starting to build user interfaces and can show you what it's like on the wrist without you having to spend days or weeks of actual programming. And from an internal company kind of buy-in perspective, you can get feedback from your manager or whatever else about how it looks. But it turns out you can go beyond that. There's some tools that allow you to very quickly build some more professional mock-ups. So for example, there's a website called GlassSim, and what you can do with GlassSim is you go to this website, and they already have on the website pre-populated a bunch of Google Glass templates for different screens, and you can add just a little bit of text here or upload your own images, and it will simulate the view through Google Glass and then generate those screenshots for you. So if you want to be able to build a storyboard of what your app would look like, you can go here, generate all the screens, and then print them out for you as well. So they have a simple card builder, and you just put some simple HTML code or upload some images, and you can build interfaces like this. There's also available a number of websites where you can download user interface templates for Photoshop and for Illustrator. So here's some example slides from templates. Similarly for watches, also you can download entire storyboards. So once you start putting some screens together, what you really want to be able to do is link the screens and talk about the application flow. You know, if you're on this screen here, what happens when you select menu item number 3? And when you tap on this one, what's going to happen? So typically then you take the sketches you've designed, the Photoshop slides or user interfaces, and you link them together in an application flow. So this says that if I tap on this slide, it's going to load up this image. If I slide to the right, it's going to load this one. If I tap, it's going to go down to the sub-menu, and I can slide across these other menu options here. So it turns out Google has made a tool for you that does this. It's designed for glass, but you can also use it for mocking up screen flows for Recon Jet or for other wearable systems. So they have this Google Glass Wear Flow Designer that allows you to quickly lay out screens on a web page and see how the interaction will flow between them. Now, I don't think I'm on the web anymore, but I can show you, I preloaded something. Here, no, where is it? Yes, so this is the Glass Flow Designer. Being Google, of course, it runs inside the browser, and so you can arrange all your cards here. You can right-click and insert a tap item, and now it says now I've got a screen tap on there, and I can add a new card. You can double-click and add different types of cards, add a screenshot. There's different types of templates here, so you can make an author card or a column card or whatever else you want to do. So it's a very nice tool that Google provided for designing the interaction flow of your mobile app or your wearable app. There's another really useful tool called Android Design Preview. This is a really great piece of software. What it does is it takes a portion of your desktop and it mirrors it onto an Android device connected to your computer. So for example, if I've used PowerPoint to build a bunch of screens, I can then run this piece of software, and then the PowerPoint screen will appear on my glass display. So that's really powerful because it means I don't have to do any Java programming or Android programming or anything like that, but I can test what it's like to interact with the interface right there and then. So anybody who can use a computer and put an image on the screen can use this to have that image appear in the display. And then, of course, if I want to test interactivity, I can use my mouse and click through and have things happening on my desktop, but it all appears on my glass display. However, some of the limitations with this is that this is really good for documenting screens, and it can show the application flow, but it doesn't really show the transitions between the screens, and it can't be used for real testing on the wearable device, and it also, you can't deploy it on the wearable. It's not actually building an Android APK file. Those of you excuse me, who are user interface designers will know that it's really the transitions between states and the screens that are really the key. So the experience in your user experience is really what happens when you push a button and then something happens. So as a designer, you've got to design those experiences. And one way you can do that is through video sketching. So if you've got your interface screens mocked up in some Photoshop or PowerPoint or whatever, and you take a bunch of snapshots of them, you can string them together in a short video clip and produce a video of what it would look like to interact with them. So here's a little example of that. This is a user interface that was designed by a designer for, I think some of you may know the application Vine that runs on your mobile. So you can record, I think it's 3-second movie clips. So they're thinking about how you could run Vine on a wearable display. So in this case, it's Google Glass. So they say start a Vine. So they go, OK, Glass. And they go start a Vine. So it starts recording. And then it records the video. But he made these screenshots and then linked them together into a small video clip. I think I may still have the video uploaded. Let's see here. No, that's Glass. Oh, here we go. So this is the little Vine video running, looping. You can see it's it shows the menu commands going there. It's only really a 4-second video, but it shows quite clearly the transitions between the menu states as you are using the software. And in fact, Google themselves did this. Those of you who remember the first Google Glass videos that came out, they made mock-ups of the user interface. And at that time, it was this bubble interface. So here's the bubble interface. And you were walking around New York, and you had bubbles appearing around. And so they mocked all this up. Now, of course, the interface they finally decided on was very different from this, but it was a nice concept video. So the next really important tool I want to talk about is a tool called POP. If you're design any type of mobile device interface, wearable or regardless, this is a really fantastic piece of software. And what POP is, it's a piece of software that lets you sketch interfaces on pieces of paper and then link together the pictures of those pieces of paper and create hotspots on the paper. So by using POP, you can draw the interface on the paper and make it interactive in just a few seconds. So basically what you do is you draw your interface on a piece of paper, you take a photograph of the piece of paper, and then you highlight the areas that you want a hotspot added to, and then you can simulate the interface on your phone. You can also send the link to somebody else, and they get the link and they download it, and they can simulate it on their phone as well. So if any of you are Android, 5 minutes, great, thanks. Android developers or iPhone developers, this is really, really powerful. So let me show you a simple live demo of this. Hopefully, if I don't kill myself. Okay. So that's my screen on my iPad here. And let's see, if I go to this previous project, okay, so you can see here's a project that I did before. So you can see super bad sketches on paper. And then if I run this, what happens is it goes into full screen, and then this is supposed to represent, it's sideways, but those are supposed to represent augmented reality hotspots in the real world. So I touch one of these hotspots, it jumps to the next screen. And if I want to, I can escape out of that. Oops, sorry. And let me show you how you can add your own screen. So I take a piece of paper and I draw on the paper a little user interface. So here's a small user interface I just drew, and I can then turn the camera mode on, and I can take a photograph of that here. Okay. And why is it not doing the next? Come on. That's very strange. Okay, so now it should have. Oh, it didn't store it. I think I have a fat finger problem and I can't quite tap the icon I need to on here. Okay, we'll move on. But I think you get the idea. So if any of you are doing any mobile development, I can highly recommend using POP. And what you can do is you can draw your screens for your wearable interface on here, and then you can link them. That's interesting. Together to be able to build your test application. So the next step is interactive wireframes. So there are a number of tools you can use to build wireframes that let you click through. And these are web-based design tools that let you develop user interfaces again without any coding. So for example, UXPin is a tool that lets you drag and drop on the screen and arrange items that you can click through. One of my favorites is proto.io. This is a drag and drop tool that runs on the web, and you can use it to prototype a smartphone or mobile wearable applications. So for example, this is the Proto.io website for Android Wear demo, and I can just go there, and we can zip along here. And if I go, let's see, here. This is the Android Wear demo. Once you've built your demo prototype, it runs on the web. And so now I can run this like an Android Wear app. So I can scroll up and down, I can scroll right to left, and so forth. And to build that, you just use this little interface here. So if I go, oh, I'm not on the internet, okay. So there's a very simple web-based drag and drop interface that lets you just drag icons, elements together and add links between them and interactivity. So you basically have this canvas. You can then take the flow you designed before, create a bunch of images on the canvas, and then link them together with gesture-based interaction. So with Proto.io, it supports tapping and swiping gestures. So the last thing I want to talk about, but we're just about out of time. So do we need to finish at 10:45, or can we go a few minutes longer? Or okay, great, sure. Well, I'll just, if you indulge me for a couple more minutes. For those of you who do know how to program, even just a little bit of programming, there's another very powerful tool that I want to talk about, and that's processing. One of the limitations with wireframes and some of the software I've shown you is that you can't deploy on the real device like I showed you before. You don't have access to the sensor data like the camera or the GPS or the orientation sensor. There's no video feedback, and there's no conditional logic in your transitions between states. So there's a language called processing. How many of you know processing? Anybody? A few? Great. So processing is a programming language designed for artists. So the idea was that you should be able to take small snippets of code, combine them together and build applications. So it's really about a language of interaction. And it turns out there's a very large community around processing at processing.org. And also at openprocessing.org, a website where you can see thousands and thousands of example code. So if you'd like somebody's code, just take it and put it into your project. But one of the really great things about processing is that it has fantastic support for Android. So what that means is that with just a few lines of code, you can build an app that will then deploy on your Google Glass or your Recon Jet or other Android device. So they have this very simple development environment, and this is all you need for the code. So here's your simplest processing application, just 3 parts. One part where you set up your global variables, one part where you have a setup function and this draw function. So this happens once when you start the application, and this happens over and over again as fast as it can go. So the other thing with processing is you can import libraries from other people, and it turns out, if I go a little faster here, there's this really great book called Rapid Android Development, and this guy wrote the Keitai library. Keitai is Japanese for mobile phone, and this processing library gives you access to all the GPS, compass, sensor data on your device. So you take the Keitai library, you can combine it with processing, and now you've got access to the camera, the GPS, the orientation sensor of your Google Glass display. So the last thing I want to show you is just a very short demo of building an app and processing, and then we'll call it quits. So, with a programmer, as a programmer, you always have to have a Hello World app. And those of you who are Android Java programmers know that it takes quite a lot of time to build a Java Hello World. Well, you have to deal with Eclipse IDE and all that kind of stuff. With processing, this is your basic Hello World app. So you have an image file, you load the image. In this case, I've got a JPEG file with OK Glass, and then you draw it on the screen. So let me show you a demo of that, and then we'll finish. So first of all, let me put my glass display on here. And it's a little bit hard to see what I'm seeing on the screen, so you can see here. So this is what I'm seeing on my glass display. And now what I'm going to do is swap over to the processing environment and open, where did I put it? Here we go. Open my Hello World app. So here's the Hello World. If I just zoom in a little bit, you can see it's the same code as there. Just load up an image, and then let's zoom out. And now we're going to build it. And what you'll see is on my display here, you'll see the image appear on my display. And the Hello World image has an OK Glass, and I think the timer is set to 5:59, so if you see that. So this is the whole development environment, nothing like Eclipse IDE or anything like that. You just push this button right here, and it starts compiling. You'll see a bunch of text appearing at the bottom there. And if I move it out of the way and push this window forward here, you'll see it says it's building the Android project. Then it generates the APK file and pushes it onto my display, and there it is. So this is, actually that's not it. It's still starting. There we go, 5:59. So now it's pushed the display onto my display here. So just with, 9 lines of code, I can now show something on here. Okay, so that's everything I want to talk about. There are a few more things, but what I wanted to do was just give you my email address. And if you email me, then I will send you all the slides, and I will also share with you the videos that I showed you. So please email me at mark.billinghurst at the new email address, unisa.edu.au, and all the material I've shown you I'll give to you, as well as links to other resources as well. So hopefully you found that helpful, and I'm happy to stick around during the break for the next few minutes, ask the questions. Otherwise, I guess we've got another course to go to in 10 minutes. Great.
Thank you very much, Mark.
Great,
unfortunately, we don't have time for questions.
No, that's fine.